Alright, and welcome to the last page of section 2. And we're going to work on one example, and that is going to be, we have the differential equation, y prime is equal to 2xy, so it's a separable differential equation, and we're actually able to solve that. But we're going to use Euler's method to obtain a 4-decimal approximation of the indicated value, first using h of 0.1 and then use h of 0.05. And then we're going to find explicit solution for each initial value problem, and then construct tables that are similar to what we have here, down here at the bottom, where we'll find n, x sub n, y sub n. We'll find the actual value, the absolute error, and the percent relative error. Alright, so let's go ahead and do that. And, I'm just going to do like the first two by hand, because it's a lot. Right? I mean, I have 2 steps. I have steps of 0.1. So what we want to do is we want to go from 1 to 1.5. So that's 5 steps. But when we do 0.05 as a step, that's going to be 10 steps of me plugging in. And that's why I say go ahead, use a calculator, use Excel to find these values. Alright, so the first thing we're going to do is I'm going to show you how to do kind of like your first table. So we'll say n, that's going to be x sub n, it's going to be y sub n. Now, the first n is going to be 0, the second is going to be 1, 2, 3, and then, I need to make a bigger table, 5, alright? And then, we're going to plug in our x sub n, so we're starting at 1, and we want to end up at 1.5. So we're going to have a 1.1, 1.2, 1.3, and 1.4, because our first h is going to be 0.1. Alright, so this is when our h is equal to 0.1. Let's say 0.1. Now, our initial y sub n, so this is going to be y sub 0, which is just 1. So we don't have to worry about that. Now we want to find y sub 1. So to find y sub 1, if we're using Euler's method, it's going to be y sub 0 plus our step, which is 0.1, times our function of our previous x and y, so 1 and 1. So what we're going to do is we're going to plug that into the function, and we're going to get y sub 0, which is 1, plus 0.1, and then times, plug in our values to the function, 2 times 1 times 1, well, that's 2, and then we're going to get 0.1 times 2 is 0.2, so 1 plus 0.2 is 1.2. So we found our first y sub n. Now I'm going to do it one more time. I want to find y sub 2 because I'm not going to do this over and over and over again, so that you can find all your values. So we have y sub 2, so that's just going to be y sub 1 plus 0.1 times f of the previous x, which is going to be 1.1, the previous y, which is 1.2. So we're going to have 1 plus, our y sub 1 is 1.2 plus 0.1, and then we have 2 times 1.1 times 1.2. Well, 1.1 times 1.2 is 121, plus another 11 is 132 times 0.1. So 1.32 is now 0.132. And then we have 0.1 times I actually went ahead and did that. So right now it's 1.32, and then it's going to be 0.132. So, I forgot to multiply the 2, so it's actually 2.64. That's what you get when you do mental math. And so when you multiply, it's going to be 0.264, and 0.264 plus 2 is going to be 1.464. So that's going to be our next value, 1.464. And then you continue the same process. Y sub 3 is going to be y sub 2 plus 0.1 f of the previous x and y. And then now I would start to use a calculator. And you'd find your next value. Alright, and so you find all your values this way. Once you've done that, then you're going to try to find, okay, what is the absolute actual value? Let me move all this out of the way. Didn't grab everything. So I'm just going to move that down there. And then I have actual value. Then I'll have that relative error. Absolute error. And then I have percent relative error. Alright, for that last value. So again, actual value, I actually need to solve this differential equation. So to find the actual value, I have to solve that. So we're going to solve that together. And then I'm just going to show you the formula again for absolute error and percent relative error. So to find the solution to our differential equation, you should be able to do this on your own by now. We have y prime equals 2xy. So I'm going to have dy over y is equal to 2x dx. Take the integral to both sides now. To integrate left and right. I'm going to get natural log of y on the left. On the right, I'm going to get x squared plus c. Let's go ahead. I could go ahead and solve for c now. I'm going to go ahead and solve this explicitly. So put my e's to both sides. So y is equal to c e to the x squared. Now, let's go ahead and plug in our value. Our initial value is going to be 1, 1. So 1 is equal to c e to the first, which is just going to be c is equal to divide e to both sides, so 1 over e, or e to the negative 1. So therefore, our solution is going to be y is equal to e to the x squared minus 1. Because we would get, since c is e to negative 1, we just combine our exponents together. So there's our solution to our differential equation with the initial value 1, 1. So to find the actual value, since this is f of xy, like this is the original f of xy, we can find, okay, well, if we plug that in, we plug 1, 1 in, we're going to get the actual value of just, I'm sorry, make it this way because I already put it in terms of x. It's not f of xy, it's just going to be f of x, and I'll put that little f there. So when we plug in 1, we're going to get 1. So our actual value is 1. So then the absolute error is just going to be the actual value minus the value that we got, which in this case is 1, 1. So that's going to be 0. And then the percent relative error is also going to be 0. All right. The next one, we would plug in the 1.1 and find it that way. And so you do the same process over again. And what's going to happen, I'm going to go ahead and show you kind of the answers now. So I'm going to kind of erase all of this. So hopefully you have this. So it's going to be a good idea to watch the video to find this. And then I'm going to put up the answers. So it's going to kind of like be paused. And then it's going to pop up. Alright, and so here's our tables where we made an Excel, or, from this program right here, able to do this off of a statistics software where it's, it's a lot better than Excel. And so what we have, again, we have the actual values where, again, the actual values are where we plug in our x's, all these x values, into what we solve for. And we're going to be able to determine the actual value. That way we can get the absolute error and the percent relative error. Alright? And then we're just going to do the same thing, but now these are steps of 0.05, and so instead of doing that over and over and over again, I can just plug it into the program. Again, we're going to plug these values in, that to find the actual value, and then all these values are going to come from using Euler's method. Alright, now again, if you have any questions about this, please ask me. It's something that's not very difficult, but it helps us find solutions to differential equations that we really can't solve. And again, we're not really going to be able to do this part when we actually need to use Euler's method, because we can't really find the actual value because we can't solve the differential equation. But again, this is just practice. Alright, well, I hope that y'all enjoyed this one. Again, it's really a short lesson, and again, I want you to use a computer software program, so kind of like use Excel. You can use Google Slides. You can use your graphing calculator if you'd like to program it. And so all you have to do is make it and then just hit enter, and then all your values will be there. Alright, and again, if you need help setting up an Excel, please let me know, and then I'll help set that up for you. Alright, well, I hope y'all enjoy this, and y'all have a great